What is serverless? This question puzzled me for a long while. When I started learning about it, the first lie I've discovered was that unlike what is disclosed by its name, serverless is not about running an application without a server. It's rather about taking the server out of your concerns as the application owner. Over the past years, the software industry has come out with a lot of innovation to optimize the management of the underlying physical machines that our code runs on: virtual machines, cloud computing, containers, and serverless. This latest paradigm is the fastest growing cloud service in the market. It is worth putting some precise explanation around this computing model so that we can at least clarify our understanding of what we are getting. In this video, I will share some enlightenments on this topic. I will drill into a bit of terminology, then I will explore the benefits and drawbacks of this technology. I will tackle as well what differentiates it from other cloud computing approaches by answering some key questions around the subject. Lingo. Autoscaling. Autoscaling is a cloud computing method that dynamically adjusts the amount of computational resources in a server farm based on the load on the farm. For example, we may automatically increase or decrease the number of servers running behind the web application based on the number of active users on the site. Since such metrics may change dramatically throughout the course of the day and servers are limited resources that costs money to run even while idle, there is often an incentive to run just enough servers to support the current load while still being able to support sudden and large activity spikes. Key advantages. Autoscaling helps to reduce the number of active servers when activity is low and launch new servers when activity is high. This practice is closely related to the idea of load balancing. If you have your own physical infrastructure, autoscaling allows some servers to go to sleep during times of low load, saving on electricity costs as well as water costs if water is being used to cool the machines. Autoscaling can make lower bills if you use an infrastructure hosted in the cloud. That's because most cloud providers charge based on the total usage rather than maximum capacity. Autoscaling can handle unexpected traffic spikes better. A static scaling solution might schedule some servers to sleep at night when the traffic is unusually low. But if there is a viral news event, people might use the internet more at night, which might cause downtime with a static scaling solution. AWS, Microsoft Azure, Oracle Cloud, Google Cloud Platform, and Kubernetes Horizontal Pod Autoscaler are examples of practice using autoscaling. Load balancing. To make the overall processing more efficient, we distribute a set of tasks over a set of resources, computing units. We call this process load balancing. It aims to optimize the response time and avoid unevenly overloading some compute nodes while other compute nodes are left idle. Backend as a service, or BaaS. Backend as a service is a vendor-hosted, highly scalable data and logic component that handles developers' needs for databases, messaging platforms, user management, push notifications, and more. BaaS applications use the vast ecosystem of cloud-accessible databases like PaaS and Firebase, authentication services like Auth0 and AWS Cognito, and so on. BaaS are typically rich client applications that offer developers a way to link their applications to backend cloud storage and APIs exposed by backend applications. Function as a service, or FaaS. Function as a service refers to the ability to write custom server-side software in small event-triggered functions deployed on a platform such as Amazon Lambda, Azure Functions, or Google Cloud Functions. These platforms take care of lifecycle management, resource allocation, scaling, operating system maintenance, and process monitoring. When these functions are connected, they create a processing pipeline or serve as components of a larger application interacting with other code running in containers or conventional servers. In serverless applications, You can configure your functions to run only when they are needed. This leads to a shorter lifecycle for them, closer to the timeline of a single HTTP request response cycle. The code activates when a request arrives. The request is processed. The code becomes dormant as soon as the activity dies down. Per request pricing model. The short per request lifecycle offers a per request pricing model, which results in significant cost savings for some teams. Since the code is invoked only when triggered by a request, the provider charges only for compute time used by that execution, rather than a flat monthly fee for maintaining a physical or virtual service. Serverless architecture. Serverless architecture is an application design for building systems in the cloud. It incorporates backend as a service, BaaS, and/or function as a service, FaaS. Today, serverless computing or serverless architecture refers to function as a service offerings in which a customer writes code that tackles business logic and uploads it to a vendor. That vendor takes care of all hardware provisioning, virtual machine and container management, and even tasks like multi-threading. Startup latency. In a serverless environment, function runs on demand as a response to a triggered event, like a user request. Since the initialization of a function instance takes some time, this approach causes what we call startup latency and cold starts. The startup latency can vary significantly. It may range from a few milliseconds to several seconds, and it depends on different factors, many of them under the developer's control. The programming language, how much code you have, the number of libraries, the configuration of the environment, and more. Cold start. Cold start refers to creating a new container instance of a FaaS or function as a service and starting its host process. Whether cold start represents a concern in your serverless architecture or not depends on the traffic and style of your application. If you are writing low latency trading applications, you probably wouldn't want to use cloud-hosted FaaS systems at this time, no matter the language you are using for implementation. Warm start. Warm start refers to the reuse of an instance of a function and its host container from previous event. Vendor lock-in. Since the serverless market is fragmented, it's likely that the features you are using from one vendor are implemented differently by another vendor. This means that if you want to switch vendors, you will probably need to update your operational tools and change your code and may even need to change your design or architecture. The risk that moving your code from one solution to another will cause you to move other chunks of your infrastructure is an idea that scares a lot of people. History of software deployment. To understand the concept of serverless a little more clearly, let's step back a little and have a look at the evolution of software deployment approaches. First, we had the bare metal phase, then virtual machine, then container, then serverless. In each of the first three paradigms, there is a concept of where your application is running, on a physical server on site, on a virtual machine, or on a cloud host or a container. The modern age of serverless computing has taken the where out of your concerns about software deployment. This age has progressed as follows. It began in 2014 with the launch of AWS Lambda, a platform based on Amazon's cloud service. In 2016, Microsoft followed suit with Azure Functions. Then in 2017, Google joined the party with a beta version of its Google Cloud Functions solution, which reached production status in July 2018. These three serverless providers have slightly different limitations, advantages, supported languages, and ways of doing things. Does serverless replace previous deployment models? Serverless is not the correct approach for every problem. It's better to see it as augmenting the previous techniques rather than supplanting them. Staying aware of your project requirements will guide you in choosing the most efficient way to launch and maintain your software platform. Large deployments, for example, may need to use a combination of different deployment approaches. It's common for GPU compute to be deployed on bare metal instead of in a container or virtual machine. Do serverless providers only take care of servers? Serverless providers have a set of capabilities such as PaaS or Firebase. They offer infrastructural services like message queues, databases, and edge caching. Higher-level services like federated identity, role and capability management, and search. Serverless versus containers. The choice between serverless, FaaS, and hosted containers may come down to the style and type of your application. Function as a service could be a better choice for an event-driven style with few event types per application component. Containers could be a better choice for synchronous request-driven components with many entry points. Serverless versus platform as a service. The key operational difference between function as a service and platform as a service is scaling. With a platform as a service like Heroku, for example, you may need to think about how many DNOs you want to run in order to scale. With a FaaS application, scaling is completely transparent. Even if you set up your platform as a service application to auto-scale, you won't be doing this to the level of individual requests unless you have a specifically shaped traffic profile. Given this benefit, why would people still use platform as a service? There are several reasons, but the tooling is probably the biggest one. The need for better monitoring and remote debugging solutions is an area that still needs significant improvement in the serverless market. Does serverless take DevOps out of our concerns? Serverless doesn't mean no ops, although it might mean no sysadmin. Ops refers to a lot more than server administration. It includes monitoring, deployment, security, networking, support, and often some amount of production debugging and system scaling. All these problems exist with serverless applications, and we need to deal with them. We are just outsourcing the sysadmin with serverless. How to build a serverless application? Although there are deviations on how the different serverless platforms work, they typically follow a workflow similar to this. You implement your software and package it following the guidelines of your chosen platform. Depending on the vendor, you may need to write your software as a JavaScript function or even package it into a container. Once you've created the package, it will be uploaded to the serverless platform. The deployment will then be live. The serverless platform will manage when to create and destroy replicas of your application and will respond to increased load by creating more copies of the container or function. This lean workflow tends to be pretty popular with developers. They only need to be concerned with the creation of the software, and the serverless vendor takes care of the details. Is a microservice architecture required for serverless applications? Microservices are the opposite of monoliths, where all functionality of an application run in a single entity. The concept of microservices is an architectural pattern that has broken software into a series of small services like a search service to find out products in a database based on user search queries, a shopping cart service to manage the items that users add to their cart, a checkout service that handles the payment process. Both technologies, microservice and serverless, offer important advantages for cloud-native computing, but they solve different problems and have distinct deployment environments. In order to deploy your application on a serverless platform, you don't have to use a microservices architecture. Serverless is one way to host microservices, but it's not the only way. In addition, not every microservice could run as a serverless function. Depending on your case, it could be better to deploy your microservices inside containers. Can I run a monolith application as serverless? There is nothing stopping you from deploying a monolith application on a serverless platform, although it's difficult to imagine many use cases where this would offer real benefits. In traditional environment, you may have one long duration task performing both coordination and execution. To take advantage of the efficiencies that serverless offers, it's better to re-architecture your monolith application and create several coordinated small units or FaaS functions. What are the limitations of serverless? With the serverless architecture, developers are able to create software and not to worry about issues like hardware, operating system maintenance, scalability, or locality. That said, the serverless paradigm has many concerns. Some of them are performance. Infrequently used serverless code may suffer from greater response latency than code that is continuously running on a dedicated server, virtual machine, or container. This is because, unlike autoscaling, the cloud provider typically spins down the serverless code completely when not in use. This means that if your code requires a significant amount of time to start up, it will create additional latency. Vendor lock-in. As I've already described, no two serverless platforms are identical. They all support different languages and tools. This means you can't drag and drop a serverless function from AWS Lambda into Azure Functions without reconfiguring it. For this reason, applications and software that run in a serverless environment are by default locked to a specific cloud vendor. Security. Sometimes, a cloud vendor cannot satisfy your specific security needs. Takeaway. The way we deliver software has continued to evolve, especially since the rise of affordable and reliable cloud hosting. Serverless is a hot technology in which application code is executed on demand in response to triggers that application developers configure ahead of time. The code that runs in this way is called function as a service, and it could represent an entire application. The long-lived server applications are a key difference when comparing serverless with other modern architectural trends, like containers and platform as a service. Although it has a better division of concerns and some fascinating cost benefits as well, the serverless design has its limitations. There is still a need for a less fragmented market, better tooling and performance, and security capabilities. Whether the benefits of serverless architecture are worth the added complexity is very context dependent. Excited about diving deeper into the world of software architecture? This video is just the beginning. Check out my Udemy video course on software architecture, where I explore these concepts further and dive into real-world challenges. The link to the course is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free access to all my courses. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more updates and tech insights. See you next time.